Hello friends, welcome back to my YouTube channel. Today, we will look at some qualities, or parameters that don't change during voltage and current transformation. In the world of electrical engineering, transformers are the bedrock of power system that enable efficient power transmission and distribution, by stepping up, or stepping down voltage levels. But in the midst of this transformation, some crucial parameters remain steadfast, unaffected by the voltage changes. These constants are the backbone of reliable power systems, ensuring that the electrical signal's fundamental characteristics are preserved. Let us explore the key parameters that don't change during voltage transformation, and discover how they keep the power flowing smoothly. Stay tuned as we begin. Welcome back. If you are new to my channel, consider subscribing to my channel for more valuable content like this. Hit the subscription button so that you will be notified on my latest tutorials and updates. So, without wasting time, let us get straight to the topic of today. These parameters include the followings. Number 1. Frequency of the alternating current. In a transformer, the frequency of the alternating current, AC, remains unchanged from the primary to the secondary winding. Why does it remains constant? Transformers operate on the principle of mutual induction, which relies on alternating magnetic fields. The primary side of the transformer has uniform frequency waveform. The induced EMF in the secondary coil is directly related to the time-varying magnetic field produced by the alternating current in the primary coil. Therefore, the frequency of the secondary side of the transformer is a copy of the primary side. The reason being that, if the input is 50 Hz or 60 Hz, the output will also be 50 Hz or 60 Hz, respectively. This is crucial in power systems, since our devices are designed to operate at a specific frequency. Number 2. Power during transformation. Here, we considered ideal transformers. The power input from primary side is equal to the power output for secondary side, in an ideal transformer. This principle ensures energy conservation and enables correct sizing of equipment. Although in practical transformers, there are minor losses due to heat, hysteresis, and eddy currents. But high-efficiency transformer designs minimize this. Therefore, in practical transformer, there is a little deviation between input power and output power. But ideally, power remains constant. Number 3. Phase sequence. For three-phase transformers, the phase sequence remains unchanged from input to output. Examples like phase A, phase B, and phase C, which is also equivalent to red phase, yellow phase, and blue phase respectively. It is necessary because the phase sequence ensures motors and rotating equipment operate in the correct direction. Wrong phase sequence could reverse motor rotation, potentially causing mechanical damage or safety hazards. Number 4. Magnetic flux produced. The magnetic flux in the transformer core links both the primary and secondary windings and remains the same. This is because the changing magnetic field created in the core is common to both windings, allowing for the transfer of energy. This shared flux is essential for voltage induction, and is constant in magnitude, especially in ideal operation, and phase relationship across both windings. Number 5. Waveform of the source. The waveform is typically sinusoidal. The waveform of the input voltage and current is preserved and the same as the output side of the transformer. This is because the transformer does not modify the shape of the waveform, it only changes its amplitude. Note, if the input is a pure sine wave, the output will also be a pure sine wave. Therefore the waveform doesn't change. Number 6. Core material shape. The core material of the transformer is a constant physical property. The core is usually made of laminated silicon steel. It is designed to maximize magnetic efficiency and minimize iron losses. Note, as the core material doesn't change during operation, its properties, like permeability and saturation level, significantly affect transformer performance. Therefore the core material doesn't change in shape, but only its properties is adjusted. Number 7. Transformer turns ratio. The turns ratio is the ratio of the number of windings on primary to secondary. It is a fixed design parameter. It determines how much the voltage is stepped up, or stepped down. Since it is built into the transformer's structure, it doesn't change during operation, unless the winding is physically altered. Number 8. Phase shift. Depending on the transformer connection type, either delta to Y or delta to delta connection, a fixed phase shift might be introduced, but it remains consistent. If there is a phase shift between primary and secondary, it is determined by the winding configuration and does not vary with time or load. For instance, a delta to Y transformer typically introduces a 30 degrees phase shift, and this shift remains constant during operation. Number 9. Harmonic content. The harmonic content, which refers to distortion in the waveform due to nonlinear loads, remains unchanged through the transformer. This is because a transformer does not filter harmonics, it transfers the waveform as it is. Harmonic distortion present in the input voltage will be reflected in the output voltage. Unless external filters, or special transformers, like K-rated transformers are used, if harmonic suppression is needed. Therefore the harmonic content doesn't change during transformation. In conclusion, understanding the parameters that remain unchanged during voltage transformation in transformers is crucial for designing and operating efficient power systems. These unchanging parameters like frequency, power, phase sequence, and waveform shape ensure that electrical signals are transmitted reliably and consistently. By recognizing the importance of these constants, engineers and technicians can optimize transformer performance, minimize losses, and guarantee the stability of electrical networks. Here, we bring to the end for this class. Thanks for tuning in. If you are new to my channel, I would love for you to join the community by subscribing. You will get notified about my latest posts, and I look forward to sharing more helpful content